Hello, thanks for watching this video. I would like to explain the software side of my temperature measurement system. And as you can see, the program is running. The system is sensing a room temperature of about 22.6 degrees Celsius. It is shown it displays the ambient LED on, because I actually set it the limits to be anything above 26 degrees will become high temperature. Anything below 20 degrees will be classed as a cold, and of course everything in between will be classed as ambient. I did that just to facilitate and speed up the process for heating up and cooling down the thermistor. So I would like to start with the block diagram, which is this panel on the right hand side. So I will just expand it so you can make it bigger, you can see everything. There are 5 main areas of the program that I had to write, and as you can see, everything is contained within the while loop, which is running it constantly, no stop, at the interval of 10 milliseconds every time. So let's start with the beginning. Everything basically starts from this pellet here, which is called analog input. Okay, let me do the highlight execution, which is going to be outputting step by step what's going on in the system. So my Rio is sensing through the analog input. There are 2 inputs into it. One is the voltage output of the thermistor, and there is the voltage supply. Why is that? Because at the moment the working principle of it is the voltage divider. So my Rio is actually executing this formula to calculate the resistance of the thermistor, and then this resistance value is actually used in this other formula node to calculate Steinhart and beta equations, which then are outputted on the user from panel. I will be quickly going through that later. So as you can see, there are inputs for this formula node, which are the coefficients calculated online that I used online. And after that, the temperature is sent. The temperature values are sent to this case structure, which is controlled by the temperature selector, which is this little controller. So as soon as I change, hold on, let me deselect this one. As soon as I change, as you can see, the temperature is automatically recalculated accordingly to the unit selected. So in here you can see there are set some limits. As I said before, anything between 26 and 20 degrees classed as ambient, or anything above 26 is classed as high. So let's move forward, going to the if and else structure. So of course the MyRIA, it has to be educated, and that is done through these selectors. So every time that the temperature is sensed, there is sent an output, digital output to the LEDs, and that is going through this structure. So as you can see, every time, for instance, the temperature is greater than 26 degrees, the signal is sent through this structure, which is becoming true, and sends a number 5 to this case structure. A number 5 will correspond to this LED become true, which will be going to this output, digital output, and that will trigger on the high temperature LED. The best way to understand that is just to play around it. So basically, I'm gonna try to heat up the the temperature. As you can see, I just put like a hot mug full of water on top of the thermistor, and the temperature is rising quite quickly. Meanwhile, you can see that the resistance is going down, so the high temperature light is on. And now we'll try to cool it down. Okay, let me pause it so you can appreciate the difference between Steinhart and beta equations. So, okay. Now we'll try to cool it down, so it will go from ambient to low. You can see below 20 degrees, it goes on the low effect. And yeah, that's pretty much everything from for my video. And as you can see, there is a stop arrest system, different values outputted like voltage supply, voltage output from the thermistor. The temperature is displayed on here. If I change, as I told you before, it changed to different degrees. At the moment it's displayed in Fahrenheit. So that's everything from me, and thank you very much for your attention.